Okay, so that concludes our sine examples that we saw in the previous videos. And really what I want you guys to do is, if you can, scan in this QR code right here and just take a look at, use it as a discovery of the comparison between sine and cosine. Now I can't animate it right now on because I'm just using a PDF, but it will take you exactly where this program called GeoGebra, and it's pretty slick. I would think that you might want to check it out and see how those interact with one another. But at any rate, the cosine wave is, here's the attributes of it before we start our example of graphing one. Okay, so almost identical as far as this business of the attributes. So we have to sine, I should say. And so we have amplitude of 1, okay? And the period is going to be the same. Remember, that's the distance where the graph starts to repeat itself. And going from here to here, exact same deal, 2 pi. There isn't any phase shift because we're not moving left to right any, and we're not moving up and down any for the vertical shift, but it works out the same way. You just start with a different parent graph, and basically it's the sine graph that is going to be shifted to the left 90 degrees or pi over 2. So we'll see. So the x-intercepts are going to be basically in this case where we're going to start off with the first positive one, which is going to be pi over 2, plus the distance in between each one, which is going to be pi n, where n is an integer, comma 0. And that will give us all of the x-intercepts from there on out. Okay, so we got pi right here and pi right here, etc., etc. And y-intercept is going to be 0, 1. Domain is negative infinity to a positive infinity. And the range is going to be just like sine, negative 1 to positive 1, including those. Okay, so in the video coming up next, we're going to take a look at this business of graphing cosine.